So for the last part of the video in section 5.5, we have to be able to factor with exotic exponents, and I need to just a little bit of a review. If I ask you to factor x squared plus 3x plus 2, hopefully you know that this is a double plus. The first need to be a couple of x's. The numbers have to multiply to 2 and add to 3. They need to be double pluses. It's going to be 1 and 2. I could multiply. I say this is how it factors. I'll show you that this checks. To check this, I'd go x times x, x times 2, 1 times x, and 1 times 2. X times x is x squared. 2 times x is plus 2x. 1 times x is plus 1x. 1 times 2 is 2. I combine these and get x squared plus 3x plus 2. That's basic factoring. And what we're going to do in this last part of section 5.5 is factor with new exponents. If I changed this problem, if I didn't change the numbers but I changed the x's, it's going to factor similarly. It turns out as long as the middle exponent times 2 equals the first exponent, then factoring doesn't change except for what goes in the first parentheses. So these two problems are structurally the same. They have a plus 3x and a plus 2. And the letters, their exponents are a multiple of 2 apart. The middle exponent times 2 gives me the first exponent. Here the numbers are plus 3 and plus 2. The middle exponent times 2 gives me the first exponent. When that's the case, the only difference in the factoring is instead of having x's up front, which is the middle x, I'm going to get x squareds up front. I claim that this problem is going to factor into x squared plus 1 times x squared plus 2. And I'll show you that this checks. If I want it to check this, I'd multiply x squared times x squared. I'd multiply x squared times 2. I'd multiply 1 times x squared. And I'd multiply 1 times 2. X squared times x squared, I technically add the exponents and get x to the 4th. 2 times x squared is positive 2x squared. 1 times x squared is positive 1x squared. And 1 times 2 is positive 2. I'll combine those, and when you're in the adding part, the exponents don't change. So these two, because they're structurally the same, they factor structurally the same. It doesn't matter where I put the exponents. As long as I have a plus 3 and a plus 2, if the exponent in the middle times 2 is the exponent on the end, it's going to factor similarly, other than the exponent's going to change. So to factor x squared plus 3x plus 2, x to the 4th plus 3x plus 2, x to the 6th plus 3x plus 2, they all are going to factor with a plus 1 and a plus 2. The only thing is the first term is going to have the power of the middle exponent. I won't check that, but I'll factor it. I could even have something like this. X to the negative 2 plus 3x to the negative 1 plus 2. If I look at this exponent and this exponent, the middle exponent times 2, negative 1 times 2 is negative 2. As long as this exponent times 2 gives me that exponent, 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2, negative 1 times 2 is negative 2, then these things will all factor the same way. The only difference in the factoring is the first term. The lasts are determined by this plus 3 and this plus 2. The firsts are determined by the middle power of x. That works 100% of the time as long as the x's have an exponent that are a multiple of 2 apart. Each of the problems in the 20 through 29, the end of this section, the first step is we're going to factor, and it's going to be factoring with these exotic exponents, which isn't particularly hard, and then we're going to solve. And we're only going to do a few of these problems because the algebra can get pretty funky, and they're hard to check because some of the answers have i's, and my calculator really can't do I to the 4th power. I'll probably check one of these, but I won't go too deep into the checking. So I'm going to start with number 20, which has an x squared and an x to the 4th. The first thing I'm going to do is factor. And I know that to lead off my parentheses, I'm going to get a couple of x squareds, specifically because that's the middle exponent, and these are set up that the middle exponent times 2 is the first exponent. The numbers are hard. For my numbers, they need to be plus and minus. They need to multiply to -4. And they need to subtract to be 3. And that's going to be positive 4 and -1, because 4 times -1 is -4, and 4 minus 1 is 3. So for problems 20, 21, 22, and 23 that have a 4th power term and a 2nd power term, first step is to factor. So for 21, 22, 23, and 24, what these all have in common, if you have a 4th power and a square, and that's what these have, a 4th power and a square. First step to solve these is to factor. Second step is to set each factor equal to 0. I'll say move the number over. Then square root plus or minus square root to solve. So for each of the problems, 20, 21, 22, and 23, that all have a 4th and a square power, first step is to factor. After I get it factored, I'm going to set each factor equal to 0. I'm going to move the number over. I get the letters and numbers on opposite sides. For the x squared plus 4, I'm going to minus 4 from both sides. For the x squared minus 1, I'm going to add 1 to both sides. So this is setting each factor equal to 0, moving the number over, and then square root plus or minus square root plus or minus square root. This is going to give me x equal to, if I'm in mode 2, I can do the square root of -4, it's 2i. Square root of -4 is 2i, but I need a plus or minus, and the square root of 1 is just 1. I actually have 4 answers here, and they're best with a plus or minus. My answer is plus or minus 2i and plus or minus 1. This is big time optional because checking with i's and 4th power is a nuisance. My calculator can't do I to the 4th power. I don't know why. In order to do I to the 4th power, I have to multiply something 4 times. It's ridiculous. But for now, I'm going to say the answer is x equal plus or minus 2i. My best answer will have a plus or minus, and plus and minus 1. If I want to check, which I really don't, but I'll check some of these. If I want to check the x equal to 1, that's easy. I'd go, is 1 to the 4th plus 3 times 1 squared minus 4, does that equal to 0? Super easy checking. No funk there. So 1 to the 4th minus 3 times 1 squared minus 4. That gives 1. I don't know what I have here. 1 minus 3. I should have put a plus here. Duh. This should be a plus. I put a minus. 1 to the 4th plus 3 times 1 squared minus 4. That gives me 0 equal to 0. Similarly, checking the negative one, not an issue at all. I can go negative 1 exponent 4th plus 3 times negative 1 squared minus 4, and I get 0 equal to 0 just fine. It's these crazy i's. If I wanted to check 2i, my calculator can't do 2i to the 4th. I don't know why. If I tried to do this on my calculator, 2i to the 4th plus 3 times 2i squared minus 4, it can't do that. So on my calculator, if I wanted to check the i's, I can't do an I to the 4th. I have to do it 4 multiplications. So if I wanted to check this, I'd have to go 2i times itself 4 times. It's a nuisance. My calculator can't do 2i to the 4th, but it can do 2i 4 times. That's 2i to the 4th without the exponent. My calculator can do that. And then plus 3 times 2i. My calculator can do 2i squared. And then minus 4, and you get 0 equal to 0. These I don't have to check because they don't produce extraneous solutions, and they're such a nuisance to check that I generally don't check. So that's 20. Let's do 21 together, or 23 together, and you can do 21 for homework. 23 is going to have a funky answer, and I'm not going to check it. So 23 wants me to solve a to the 4th plus 5a squared minus 6 equals to 0. I'm going to factor this, and to lead off my parentheses, I'm going to get a couple of a squareds because the middle letter is an a squared. And for my numbers, they need to be plus and minus. They need to multiply to negative 6. And they need to subtract to 5. I can't use quadratic formula for 4th powers. It only works for squares. And the numbers here are going to be 6 and minus 1 because 6 times minus 1 is minus 6, and 6 minus 1 is 5. So one parenthesis is going to get a plus 6. The other is going to get a minus 1. So first step I factored. Second step, I set each factor equal to 0. Then I move the number over. So I factored, set each factor equal to 0, move the number over. Now I'm going to square root plus or minus square root. Prefer using my calculators to reduce these square roots because it's just so much easier than having to think. The square root of negative 6, if I'm in mode 2, square root negative 6 is just radical 6 times I. Left-hand side, when you square root it, you just get a. And on the right one, the square root of 1 is just 1. So my answer is going to be, for 23, plus or minus rad 6i, and plus or minus 1. I should probably write a equals, but if I don't, it would be wrong. So that's 20, 21, 22, and 23. What they all have in common is they have a 4th and a 2nd power. This is the kind of problem that makes it on the test from this grouping. The next group of problems that we're going to stop at, we're not going to do 26, 27, 28, and 29. We'll do 24 and 25. First step, exactly the same. I'm going to factor. Second step, I'm going to set each factor equal to 0. Third step's going to be different. I'm going to make fractions and cross multiply. each one of these problems has a different solving strategy, and these problems down here would have a different solving strategy than this. I don't want 4 solving strategies. So for 24, maybe it's not big enough, so let me make it bigger here. I'm going to factor this, and because the letters are a multiple of 2 apart, I know the parentheses are going to lead off with this x to the negative 1. For my numbers, they need to be plus and minus. They need to multiply to negative 8 and subtract to 7. And that's going to be 8 and negative 1, because 8 times negative 1 is negative 8, and 8 minus 1 is 7. So one parenthesis is going to get a plus 8, the other is going to get a minus 1. So first step was to factor. Second step, set to 0 and isolate the number. So I'm going to go x to the negative 1 plus 8 equals 0. X to the negative 1 minus 1 equals to 0. Isolate the number, go minus 8 minus 8. Gives me x to the negative 1 equals minus 8. Here, plus 1 and plus 1. X to the minus 1 equals 1. This is when it gets different. Solving with squares, I can square root. Solving with negative 1 powers, I can't square root. Square rooting doesn't get rid of negative 1 powers. Square rooting gets rid of squares. Step 3, make each side a fraction and cross multiply. 1 over x is the same as 1 over x to the first. Negative 8 is negative 8 over 1. On the right side, 1 over x to the negative 1 is 1 over x to the first. 1 is the same as 1 over 1. So what I have right now is 1 over x equals negative 8 over 1, and 1 over x equals 1 over 1. So I've made each side a fraction. I made the negative exponent into a fraction using the negative exponent rule that we did earlier in this chapter and we did in chapter P. Now I'm going to cross multiply. On this left one, I get negative 8x equals 1. On the right one, I get 1x equals 1. On the left one, I have to divide by negative 8. On the left side, I get x. And on the right side, that negative doesn't have to be left in the denominator. I like it better in the numerator. The second one gives me x equal to 1. These don't have to be checked, but I can check on my calculator. I say the answer is x equal negative 1/8 and 1. Let me try to check these because I have 3 minutes left. I can jam it in here, I think. To check, the original problem was x to the negative 2 plus 7x to the negative 1 minus 8 equal to 0. The first one I need to do is negative 1/8 to the negative 2 plus 7 times negative 1/8 to the negative 1 minus 8, and that would have to be 0. I would never check this by hand, but with my calculator, not so bad. So parentheses, negative 1, parentheses, fraction, negative 1 over 8, parentheses, exponent, negative 2, plus 7, parentheses, fraction, negative 1 over 8, parentheses, exponent, negative 1, and then minus 8. And that checks, it gives me 0 equal to 0. And then the next one is going to be 1 to the negative 2 plus 7 times 1 to the negative 1 minus 8, and make sure that equals to 0. So parentheses 1 exponent negative 2 plus 7 parentheses 1 exponent negative 1 minus 8. And that gives me 0 equal to 0 as well. None of the problems in the bottom grouping do you really have to check. So in the bottom grouping of problems, just do 21, 23, we already did 23, so you could skip it, and 25. The ones with the fourth and the second power are on the test, so they're important. I never put the -1 exponent ones on the test. And these fraction exponents are a whole new solution steps, once you get it factored. The factoring is the constant, but what you do after the factoring depends on the exponent. So we'll call it quits there and just have one more section of new material to get in Chapter 5.